Most of what we've discussed in this course so far has been leading up to polynomials, and we'll be dealing with polynomials quite a bit from here on out. So let's define what a polynomial is. The prefix poly means many, and nominal or nominal has to do with names or terms. Hence the word polynomial means many terms. A polynomial is an expression that contains multiple terms and can contain variables, constants, and/or exponents. But not everything that looks like a polynomial or polynomial expression actually is one. One thing polynomials cannot contain are terms that are divided by variables. Likewise, variables cannot contain fractional exponents. Let's take a look at a couple of examples here. The first expression on the left is a polynomial. 4x squared plus 10x plus 25 is equal to 0. A similar looking expression on the right-hand side, however, is not a polynomial. Because the second term violates the rule that terms of a polynomial cannot be divided by a variable. Let's go down the line for the rest of the polynomials here. You have x squared plus 2x plus 1 is equal to 0. Even a constant by itself can be considered a polynomial expression because it doesn't violate the rules. As we said, polynomial expressions can contain variables and exponents, but they don't have to, as we just saw above. X squared plus 3x plus 1/2 equal to 0 is also a polynomial, because even though we have a division, none of the terms are divided by a variable. Same thing with the expression below it. Negative 6y squared plus 2/3 y minus 1 equal to 0 is also a polynomial, because the 2/3 applies to the leading coefficient of y. We're not actually dividing by y. And then lastly we have 3x cubed plus x squared divided by 5 plus 15. This is also a polynomial, because even though we're dividing the second term by 5, we're not dividing by a variable. To help clear this up, let's take a look at the other examples that are not polynomials. X squared plus 2x to the negative 1 plus 1 equal to 0 is not a polynomial, because if you were to write the second term according to the negative exponent rule, you would have x squared plus 2 over x plus 1. Since the second term would be divided by a variable, this means that the expression is not a polynomial. In the next example, x to the 4th plus 16 to the 1/2 plus 4 is not a polynomial, because it violates the third rule we saw above, in that a variable cannot contain fractional exponents. And then finally, x cubed plus 3x to the negative 2 plus 1/2 is not a polynomial, because if you were to rewrite this, what you would have is x cubed plus 3 over x squared plus 1/2, and again, you can't divide by variables and call it a polynomial. Let's make sure we have a clear understanding of some terms we've used. We said that polynomials consist of terms separated by operators. In the example here, the operators are plus signs, but they can be negative signs, division signs, multiplication signs. They're basically anything that you use to perform operations on the numbers. And the terms are separated by these operators. 4x squared here is a term, as is 10x and 25. Let's get a little more specific than that though. This is the example we were just looking at. Again, we have three terms separated by plus signs, which are the operators. Terms of a polynomial can have a leading coefficient, as in the case of 4x squared or 10x, and they can contain variables like x squared and x here, but they don't have to. 25 is not called a leading coefficient because there's no variable attached to it. Instead, it's called a constant, and the variables can have an exponent or not. If we were to eliminate 4x squared from this expression, we would have 10x plus 25. That's still a polynomial, but in this case we have 4x squared plus 10x plus 25, and that meets the definition of a polynomial as well. Okay, let's take a break here. When we come back, we'll talk about degrees of polynomials and how to write a polynomial expression in standard form.